talking to this group. Hopefully the audio holds up okay. I've been spending a lot of time in online meetings in recent times, and I've done the odd webinar before. One of the things about them is it can be a bit like talking to the screen for half an hour with no sort of audience participation coming towards me. So I've asked Rob to be kind of the voice of the audience. Feel free to chuck questions into the Q&A as we go along, or just as they occur to you. I might pause periodically throughout the talk just to provide an opportunity maybe for some questions along the way, because I tend to think a bit of a discussion is good, and sometimes waiting to the end doesn't facilitate that as well. So feel free to just pop questions in along the way, and Rob will pick them up, and I'll pause periodically. So without belaboring the point, let's get into it. First step, next slide. Okay, good, we're in business. Okay, so Rob's done the introduction, so we won't dwell on this. What I'm going to do this evening is work through kind of 5 main points, which is a bit of background to what Industry 4 is about. A lot of people will probably be here because they've heard the term. I'll expand a bit on what that is. Talk about what cyber physical systems are, because that's kind of core to the idea of Industry 4. I'm going to break down a series of features that build up. And it's not an exhaustive list, but things that I consider to be important to the Industry 4 kind of makeup. Talk through some examples of those, and I'm going to talk a bit about some practical applications that we're seeing emerging in supply chain. Some of which are well and truly with us, and some of which are just still coming onto the scene. And then we'll wrap it up with some takeaways. So let's get into it. What is 4.0? This is nothing you can't read by Googling the term. Basically, cyber physical systems, which I'll talk a bit more about in a minute. These are really enablers, right? On-demand availability of computer system resources, and by that we mean really powerful computers. Is one of the key things that makes this all possible. Internet of Things is another term you've probably heard, and I'm going to talk about specifically industrial Internet of Things and what that's emerging into in the, I suppose, industrial applications. And we'll talk a little bit about cognitive computing and mostly how all these things tie together to really show us how the landscape is really shifting on us. And because it is shifting, and particularly things like COVID, which has given us all a bit of a kick, have accelerated some of this for a lot of organizations because they've been forced into making change. So again, history of industries. Okay, so Industry 4, okay, but what about the previous 3? Industry 1, this is the real background. This is the original industrial revolution back in the late 1700s into the early 1800s. This is where we first got power that didn't originate from an organism, so like a horse or a person. Things like steam power, and the first sort of manufacturing machinery started to emerge at this time. Then came the second revolution, which was when we started to get really deliberate about standardization, and that enabled mass production, things like assembly lines, and the ability to transfer energy over distances, which was about electricity. And then things kind of went quiet for about 100 years, and then we got into the third industrial revolution. And this is what people used to think of as being high tech in our lifetime. And that was really about centralization of control. So, if you can imagine a Japanese car factory, or, those sorts of things, we had big orange robots doing really, really heavy duty stuff, really, really precisely, welding car bodies together and stuff. This is the stuff that emerged in that era, and carried on into the 90s, where we started to, see digital computing making its way into, the day-to-day use on operational floors. And now we're into Industry 4, which is, we're starting to see really what the guts of Industry 4 is about, is the decentralization of decision-making and control. It's easy to get distracted by things like fancy buzzwords like cyber physical systems, but really what that is about is not having a single centralized point of control. It's about distributing that control across a system of some description. And I'm going to talk a bit more about the mechanics of how that really happens. Let's take an example of what a cyber-physical system is, right? It fundamentally is what it says it is. It's something that's both digital and physical. And I'm using Uber as an example of this. This has a lot of components. Some of them are digital and some of them are physical. What is Uber but a really a fancy taxi service? It's a bit more than that. And what sets it apart is having this really powerful analytics and real-time information system sitting in behind the bit that the people see. Some of the parts of the system are not under the control of Uber, right? There's other road users, there's roads, there's non-Uber customers. And what it does is it navigates that environment using real-time analytics. So you'll see it, your experience of it as a customer is going to be, you want a service, you get a service, and it does it well. But behind that, it's also, the customers are also the drivers. And what it's about is about high levels of asset utilization by keeping these guys busy with work a lot of the time. It does that a lot of ways, but some of it is things like demand forecasting and predicting where the work's going to be and guiding drivers into the right location so that they're available to deliver a high level of service. So I think what I'm trying to do is paint you a bit of a picture that shows that, there are a lot of enablers to this. One of the really key ones is you think about the things that would have had to be in place for something like Uber to come along. So the first one is widespread smartphone ownership. So you've got a device in your pocket that has more processing power than computers that we cut our teeth on 20 years ago. Connectivity in terms of data everywhere, high availability, low cost connectivity is really key to this. Something like the Google Maps API, which is not something that Uber ever set out to invent, but it absolutely uses it. And certainly in transportation and logistics, you'd see, this is just relied on so heavily that it's just part of the decor now in a way, but it's a hugely powerful tool. Its ability to do things like route finding, which I remember when I was a student was considered to be a really cutting edge problem. And the fact that it can do it in real time now is, mind blowing in a certain respect. I talked a bit about being predictive. So, Uber's analytics are predictive around things like weather, things like events. So it knows when, there's big sports events on and things, assuming we've got the right to assemble. All those sorts of things. And it uses those to make sure that it has the right resources in the right places so that it can get as much as it can out of the world. And you'd have to say that the extension of the Uber principle is they're not really interested in the taxi service. They're interested in, I'd have to say I think they're interested in autonomous vehicles more so than taxi services. So there you can sort of see the game they're playing. So let's talk through some of the features. I didn't list this at the top. It's sort of, again, becoming part of the fabric is big data. And here are the five V's. There's a lot of different versions of this, 4 V's, 5 V's, 6 V's. But big data is about the volume of the data, the variety of the data, the value of it, the velocity and the veracity. And okay, maybe that last one is just someone trying to find another V, but we're talking about a lot of data to get volume in this context. Importantly, we're getting a wide range of data from a wide range of sources and being able to work across that breadth of information is really the thing that's different from where we were, say, more than 10 years ago. I'll talk more about that in some of the practical examples about the sorts of information. But an example of that might be in the Uber example I just gave. In real time, Uber is able to see weather plus where everything is, plus when you've got the app open, it knows that you've got the app open. So it knows that you're interested and it's already planning that into its routing of resources before you've actually tried to book anything. So that's quite a problem to crack if you're into data science. One of the key aspects is useful data. So now the big problem is not so much capturing data, but capturing useful data or being able to filter useful data out of the background noise, because you can absolutely drown in it. And this is, again, I'll touch on this later, but this is one of the hardest things, is to measure what you want or gain what you want out of the world. Velocity, again, if we're talking real-time systems, we're talking about acquiring and processing data tremendously quickly. A stat that gets rolled out is something like 90% of all data created by humanity has been created in the last 2 years, and that's been true for about the last 10 years. So it's accelerating at a phenomenally exponential rate. You know, there's practically nothing that doesn't have a data stream associated with it now. You know, everything from people taking pictures of their cats and what they ate for dinner up to, you know, really rich industrial data sources. It's all there. And a huge amount of it is actually social data, which is quite an interesting field for a lot of people that play in the consumer-facing spaces. Veracity, I mean, one of the problems in my career to date has been, how do you deal with inconsistencies and data that isn't fully clean? How do you deal with whether you're really sure that the data is right, that it is what you think it is? And that just gets harder the more data there is. So, you know, the word data is going to come up a lot in this presentation. So, you know, we'll talk about that as we go. Let's look a little bit at industrial Internet of Things. Essentially what this is everything has an IP address. This is the kind of the core concept behind it. So your phone is a good example, but it can be anything from, I don't know, there's a pot plant here, maybe I want to know its soil moisture content in real time. That's not out of the question. Again, one of the enabling features of this is the very wide availability of cheap sensors that can be connected by some kind of network to something that captures that data. And the next slide up, I'm going to talk about what some of those sensors are starting to look like. But the diagram on the left sums it up pretty well, I think, is essentially you have a lot of devices, you have some form of connecting them to the internet, you have some way of capturing, logging, processing that data, and then you have a way for it to interface to people or other systems in a meaningful way. This can be, you know, as I say, very simple, or it can be very wide-ranging, to the point where there are ecosystems starting to crop up that I would never even thought about. I'll give you an example of it in a second. But basically, this is where you start seeing people talking a lot about cloud processing, because the volume of data is such that processing it in something that lives on your premises is probably going to be out of the question. You need some very, very powerful data centers to process this data. Let's talk about sensors. Basically, if you can measure it in any way, there is a way of connecting that into some sort of IoT device. There's a couple of examples on the left that are maybe quite common. The first one on the top left is a puck sensor. This thing goes 19 years on a single button cell battery. It can connect up to 500 meters away from, that'd be an open field with no interference, but you know, it's got a long range on it. This thing is used for sensing temperature, and you would put it in a product, or you would put it in a transportation vehicle or container or something, and it can feed back to you in real time as long as it's got a connection. That temperature. Sometimes humidity is included as well in those devices. Those of you that work in the cold chain are probably familiar with chucking data loggers into containers as part of the trust and source requirements, and this is an extension of that. These things run less than 20 bucks, maybe 15 bucks at current rates, and you can probably get them cheaper if you know where to look. The key thing there is it's Bluetooth low energy, which is touches on networks. So everyone's kind of heard of Bluetooth, and it's, you know, my earpiece is Bluetooth and so on and so forth. Bluetooth low energy is the same technology but much lower bandwidth, something in the order of about 200 kbps, which is something in the region of what a dial-up modem would have been once, but it's probably not enough to support voice, but easily enough to send a temperature reading once a second or something. So setting up sensor networks around DCs is something I think you're going to start to see more of. You might have several kinds of sensor networks. Everyone's familiar with having Wi-Fi for RF guns and things, but I think we're going to start to see another tier of network infrastructure appearing in DCs to support these types of devices. There's a variety of them: ultra-wideband, Sigfox, wide area networks. There's a whole series of those emerging at the moment. And they're not actually that new as the other things. Some of these things have been around a long time and are pretty well understood. Looking at the right-hand side, we've got there's a bit of a description of some types of sensors. If you want to measure it, you can. That's kind of my takeaway from this. This doesn't even talk about cameras and things. It sort of does, but maybe not streaming video, but certainly the ability to capture imagery. This actually leads on into something that's called edge processing, which is if you can get let's say you're interested in doing vision processing or something like that, which is quite processor hungry. If you were uploading a stream of video, that would be quite data hungry as well. The idea of getting that done in the sensor and just sending the bit you're interested in off down the network is what edge processing is about. So you start to see, I think you start to see that there's a balancing act here between data bandwidth and processing on the device or near to the device that has to be worked out in terms of the application. The second sensor I'm showing you there is an off-the-shelf location beacon, essentially. This thing's probably in about the $30 range. It's basically got a GPS geolocation unit in it with accelerometer. It's got a couple of buttons you can queue for certain things. It works over the Sigfox network, which is one of the things that's in behind cell phone stuff. You can also get these things with 4G, and 5G would, as a very high bandwidth tool that I think we're going to start to see making certain things possible that haven't been before. So again, these things are effectively sealed units. They're waterproof. You wear it on you if you fall over and when you're working remotely or whatever, you know where the person is. Let's talk about automation and specifically machine learning. So machine learning is really the word we're talking about here. Artificial intelligence is probably the more commonly used term, but machine learning is the thing. So my key point to this is what it's really great at is pattern recognition. It's got the ability to detect patterns across very wide amounts of data very, very quickly. And this is really what it's best at, in my view. This kind of stuff, there's a couple of images on the screen. It's very good at structured thinking, but the point is you can teach it. By feeding it, let's say we're identifying birds in this example. By being able to feed it images of birds, they can figure out this picture has a bird in it, this picture does not have a bird in it. Okay, cool. But you can sort of see that you build upon that process and you start to, really be able to pull out a lot of information that you couldn't get through people. I still think that the best way to use machine learning is combined with a human at the moment. And that's why I've got the weird brain on the left-hand side there. Is what you want to do, I think, is lift, and what I try to do in my business is we try and lift out the best parts of the pattern recognition and the ability to process data very, very quickly. But we've got to combine that with, well, what does it mean and what's it for kind of questions, which are a little bit different. One of the things about this is getting to the point where you're actually starting to, again, you can see machine learning working in real time. And I'm going to talk a bit about vision systems and how that plays into it as one of the practical examples. Smart factory is a term that's associated with Industry 4. And Industry 4 is a thing, I suppose, that's grown out of the manufacturing sectors. I think you need to think about this slide in terms of, well, smart industrial process, which really means smart distribution and smart supply chain as well. It's just it's not called that for some reason. The manufacturing guys got there first. I guess the key thing in this is what makes this factory smart. You know, did we just whack a buzzword on the front of it, or what? Now, I suppose I talked before about decentralization of decision making and things being interconnected. Smart factory is really about that. So if a machine goes down because there's a fault on it, everything up and downstream of that thing also stops, because they're able to make decisions that it's the right thing to do if it's lean is not to be processing right now, or something to that effect. Things like predictive maintenance activities, things like really, really fast service levels. Like, let's say a customer orders something online and it's literally going into the factory within a few minutes of that order taking place, and it's coming off the line a couple of hours later and shipping directly to them. That's the kind of that's where they're trying to get to with smart manufacturing, is incredibly fast lead times and incredibly fast transfer of information. If you extend that thought into the supply chain, it's various parts of the supply chain automatically talking to each other in order to manage inventory, manage orders, adjust what they're doing to suit disruptions in real time. So, you know, a container misses its ship or whatever, and the whole supply chain adjusts around that. Organizations that had implemented these sorts of features did better out of the COVID disruption than others, from what I've been able to see online and in the media, because they were much more adaptable, because the supply chain planning process was decentralized and adjusted very, very quickly. So there's not a lot of, it's hard to find really good information around what that really looks like in practice, because I think that's still emerging. But the key bits to it is really, really well connected stages of the supply chain, where there's decentralized planning and decentralized decision making, and they're adaptable as a result. This again leads on into digital twins, which is a word you may have seen before as well. And it's probably the thing about Industry 4 that I see misused the most in terms of what it really means. Partly because I think it's still emerging a bit, and so there isn't really a hard and fast definition around it. Again, this is something that's come out of engineering and manufacturing first, because I think some of the key components of that were available first. I'll talk to it, I suppose, in concept, and let's talk about some examples. For a long time, we've had physical assets, and we knew about them. Having a fully real-time digital copy is what a digital twin is about. But importantly, that digital twin is able to run analytics on what's about to happen, or what's shortly going to happen, or maybe even what's going to long-term happen, and it can actually step in and intervene back into the real world in time to make a difference. It may not be quite real time, but it might be in near real time, or at least within, the cycle of observe and respond. So its ability to actually influence the real world is a key thing here. So examples of that are, let's take the manufacturing environment, that there's a full digital version of your manufacturing plant available to you in real time, which is everything from operations manuals, digital models, to physical digital models like the three-dimensional model that you can actually walk around in the virtual world. Those exist right now, and they exist in New Zealand, if you don't know about that. That can link into operators through augmented reality, that can link into back of office functions. Knowing where all your inventory is in real time in a way that you can interact with it, all that other sort of good stuff. And the ability to actually, like, let's take a simulation of a process, for example. It's fed with real-time information about what's going on in that process right now. You can then run optimization on that process in the virtual world much faster than you can actually do that process in the real world, make some decisions about what to do, then tell the process what to do. And whether or not there's a human in that loop is absolutely up for grabs. It could potentially be completely automated. And then we have Skynet, and then we all know how that winds up. So again, this is one of the hardest things to achieve. I think, doing analytical work as I've done for a long time, we've always been building a digital representation of the real thing that we're looking at, but it's just the pace at which and the scale of which that information is aggregated that's different here, and it's probably 100 times harder to do. So I suppose that's all the theory and then the introductory stuff. This is really the summary point. Here are the 6 key design principles. Interoperability. So this is plug and play is what this means. So because we're not centralizing control here, we are plugging objects onto each other. We're starting to see that coming through everything from conveyor systems that use bolt sections of conveyor systems, and they know where they are and they know what they're connected to and all that sort of stuff. Interfacing between different kinds of systems. This means interface standards are emerging that people can access and use. Anyone that's done a systems integration project knows that the integration with the business systems there's going to be problems there. That's becoming easier to do through these standards, and I think we'll continue to see that interoperability thing play out, where things will just connect and work. We're not there yet, but someday. It's a dream. Virtualization. So anytime there's a physical asset created, I think we're going to see a data asset associated with it, whether that's, in the line of work that I work in, we're handing over full digital models of a warehouse design. So everything from, you can walk around in it, you can put it in virtual reality. Once upon a time, you threw an as-built drawing over the fence in paper copy at the end of the project. Now that's very much a digital asset. You start to become used for onboarding staff. You bring them into VR and you show them what they're going to be working in a year before it's ever built. You can do that with trials, and you can do design reviews in that environment, all sorts of stuff. It's getting really easy to virtualize things. We've talked a lot about decentralization, so I won't go into that further here, but really systems talking to systems, right, and being able to make some sort of decision. Section 4 is that real-time or near real-time aspect. So the ability to actually look at the world around it and take something out of that rather than simply responding to dumb stimulus. Being service-orientated, we haven't really talked about that so far this evening, but really connecting to the end user of the system. So getting out of its own way in a sense, and just making it about service levels. And modularity, which to me is very closely tied to interoperability. We're starting to see physical automation systems be easier to scale on, for example. Historically, logistics automation has been really big DCs with big fixed infrastructure, and those are certainly still going to be a thing. But the ability to scale automation to try and take some of that upfront cost out is a trend that we're seeing emerging in automation of logistics in recent times. So that's an expression of this kind of 4.0 stuff. So that's a bit of a fast blow through a wide range of topics. Got time, so I think maybe it's time to pause and maybe ask a couple of questions before we get into the practicals. Rob, is there anything that anyone that's come through the Q&A that is worth addressing here?
Yes, one question has come from Tom Street. Thank you, Tom. Given the many possible applications of IoT devices to measure attributes and variables, how best should an organisation determine where to start? Is there a guide to this strategy development?
I've actually got a section on that later on, Tom, so I'm glad you asked. I will address it later on. And the short answer is, I think we should avoid overthinking it. I think we should just pick something that's relatively simple and start. And I'll talk through some examples of some stuff I'm working on as an example of where to start with some of that. Hopefully that answers the question well enough for now. Carry on. I thought I'd, as a bit of a break between the sections, kind of pause and throw up this slide. So if you've ever seen presentations on innovation or emerging tech, you've possibly seen this, and comes up with one of my favorite phrases, which is the trough of disillusionment. I think probably New Zealand's been a bit of a New Zealand's quite an innovative country, but it is sometimes a slow adopter of some of these things. And I think from people I've talked to around the industry, there are some companies that are reasonably advanced in some of this stuff, but there's a lot that are still only getting started. And really my hope is that we can just shortcut straight across from the midpoint between technology trigger and peak of inflated expectations and go straight to the plateau of productivity. I think the 4.0 stuff is very much out of the trough of disillusionment now worldwide. It's just a case of we're pretty good at catching up on this stuff. I think we should just go straight there. So I thought I'd float that as a bit of a thought for industry generally. So let's talk about some practical stuff. So real-time order management. This is a feature that we're starting to see come into warehouse management systems or execution systems, particularly where there's automation involved in it. And what this is really about is the ability to reprioritize the order queue in real time. So let's say you're an e-commerce operation. We're starting to see internationally that the delivery or the service level expectation is getting down to hours rather than overnight kind of thing. So if you click, you expect a delivery in a couple of hours sort of level of expectation. New Zealand's always been quite comfortable that we've had a good quality overnight parcel service nationwide, which has done well for us. But in metro centres, at least, we're starting to see DCs setting up to deliver not just same day, but within a couple of hours. To be able to achieve that kind of service level, you have to be able to respond to events very quickly because there's no time buffer between you and the delivery. So that means that if you start to see weather building in one corner of Auckland, you're going to have to be looking at, well, we've got to bump those guys up the queue so we can get them out. That means we're going to have to predict that that's going to be a need. So we're going to be starting to book in transport requirements ahead of the orders dropping. So those sorts of trends are a little bit frightening again to think about how would we really manage that in practice. And it certainly can't be done without the technology. So, again, when we think about that smart supply chain concept of your DC is connected very closely to its transport providers and the customers and its upstream providers, those sorts of information streams are going to have to be very smooth for this to work. And it's being done. It's not a future kind of scenario. This is being done. It's being done as close as Australia. I'm not aware of it happening in New Zealand yet, but it's surely not that far away, at least not using technology and not at scale, I suppose. Plenty of operations can do this when they're small. It's just how do you do it if you've got 100,000 SKUs and a big warehouse. Things like process mining. So process mining is about harvesting data out of processes in order to learn things about them. This is something that combines sort of process mapping with some AI machine learning kind of stuff. We've got an evaluation license for a tool at the moment called Disco, which is about process discovery, and this is a screenshot of it. Essentially what you do is you feed it your business processes and it figures out what's happening when and why. The neat thing about it is this connects into the simulation software that we use, which means that we can export the historicals into a future case simulation and we can change the parameters. So then we can start to see, are we able to make a difference by tweaking small things, or do we have to go through a process redesign kind of exercise? Real-time location systems. Now these actually got quite a boost in the COVID era because they were used for things like contact tracing. So operations, you're wearing some kind of tag or beacon. If it turns out that at some point you were discovered to have COVID, you just run a query to say, list me all the people that were within 2 meters of this guy in the last however long. So, that's a data logging application, but equally these things can do work in real time and can be used basically anything you can fit a tag to. And these tags can be a few dollars each, maybe $5 or $6 sort of mark. Not quite, they're a step up from RFID, but similar kind of concept. and you simply ping them and triangulate them, and systems can handle hundreds of these things in a space. So same principle as barcoding. Essentially, you can see it with a network. So some potential applications for these sorts of things. I'm really interested in it from the sake of looking at congestion, which is notoriously difficult to pull out of transactional data. So if I'm looking for physical bottlenecks in a DC in terms of, have we got high velocity SKUs too close to each other that's causing pickers to back up at that location, or is that aisle just not wide enough, or what? It's very hard to pull that out of the data sources that you can get out of a WMS, short of going and looking at it. And part of this is about reducing the cost of capturing that data, because it is not cheap to stand somebody in a warehouse with a stopwatch and a clipboard, so to speak, for long periods of time. If you can pull it out through some kind of automated process, then that's actually an interesting thing to us, because it helps us do our work for less money. So other sorts of applications, safety systems. So lots of operations would have a 3-meter rule around MHE, for example. How is that really managed in practice and enforced and logged and incident identified? There's not really that much out there other than people honesty kind of statements and a guideline kind of principle. These sorts of things can alert the forklift driver in real time if someone is approaching from behind a blind corner, for example, because it's real time. So those are the sorts of things that can emerge when you have that kind of data visibility of location. Plenty of the stuff exists about GPS. It's just how do you do it inside where you don't have GPS and good quality. So we're running some investigation around this kind of technology at the moment as an in and out kind of system rather than a permanent system, because we're interested in it from running analytics. So emerging for us a bit at the moment. I thought I'd throw this one in as an example of machine learning. So generational design. This is where you basically hand the keys to the design software to an AI, and it just churns out hundreds of concepts, and learns from it and then optimizes. This is something we've been playing around with for footprint planning around DCs, trying to get the best utilization out of a site. You give it the site boundary, you give it the parameters, and you let it go for it. It's not quite at a level where it's better than I am at it yet, which is not that, well, it's probably not that high a bar to set for it as an AI, but probably speaks more to our prototyping skills than anything. But the example shown on the right here is an example of a design optimizing for, this is an architectural design, optimizing for light to workstations. So it's able to see and predict how much light will land on a workstation in an office, and what they're trying to do is either maximize it or minimize it, or whatever the criteria is to get the outcome that they want. So spatial design tools are really emerging quite a lot at the moment around that. Talk a little bit about IoT analytics, and this is kind of the guts of what I was talking about before. Is over the left-hand side of the screen here, we've got our traditional sources of data that I've historically had to rely on, which is the ERP, WMS, execution systems databases. So you come in, days or years after the fact and pull data out of that. Also fixed automation control systems and SCADA, which you can get stuff out of if you're interested in the real nitty-gritty stuff. But then we're starting to see other assets in the network that we haven't previously had a source of data around. So what we're starting to see now is we can put IoT sensors in to see all this stuff, or what we're interested in at least, and then we can put it all together. So we can pull information from this, we talked about variety of sources. Now I can pull a wide variety of information that's tailored to what I'm interested in. And potentially, you can feed that back into the operation in real time if you're really interested in it, or pretty close to real time. Because I'm not in operations, that's not my space, but I'm interested in what can we learn about it for the big picture. But you could see how this could start to turn into something that you could use in an operational decision-making dashboard or something like that, if you tailored it to your operation would work quite well. we're talking about vision systems quite a bit at the moment. This is something we're definitely pursuing because vision systems are actually in warehouses already. So one of the things, as I said, I'm most interested in is how do I lower the cost of delivering what we deliver? You know, if we don't have to set up a custom sensor network to get what we want, that would be great. If we didn't have to go there in the first place, like let's say it's overseas or it's a long way away, that, you know, saves the airfare, it saves on the carbon. That means we can respond more quickly because we don't have to book flights. You know, one of the most expensive parts of what I do is going places. So, you know, there's nothing in terms of human interaction that you can't get that all over online meetings. You know, so we still want to be doing that, but we don't want to do it for the purposes of capturing data that we can get better in other ways, and certainly better and cheaper in other ways. So examples here on the left are, this is a machine learning algorithm identifying objects in the warehouse such as forklifts and tracking them. This is really interesting to us because this allows us to do things like, if a forklift enters an area of interest on the screen, such as it goes into a drop point or it goes into a conveyor pickup or drop point, we can timestamp that. So I can produce data out of this that gives me really good time and motion data based on observed stuff. In principle, you can teach it to identify individual forklifts as well, not just a forklift, but you know, you put some kind of distinguishing mark or serial number or pattern on the side of the thing, and you can see that it was a particular forklift. You know, those sorts of things. It doesn't have to be one kind of object. It can be, it's identifying the forklift, it's identifying the people, it's identifying the pallets and the cases and whatever you're interested in. So there's a lot you can do with this kind of thing. There are some pitfalls to it, which I think people need to be very cautious of when going into this kind of approach though, which is CCTV cameras in warehouses are typically there for security or for incident safety, incident tracking, incident investigation kind of purposes. And I think you have to be very careful about repurposing a system that's been installed for that purpose into something that is now for productivity monitoring. There's a potential kind of workforce relations issue around that I think needs a lot of sensitivity. It's going to matter some places, it's not going to matter in other places. And in particular, I think you have to be quite careful when talking about using images of staff for things. You know, some people are funny about that, you know, and not unreasonably so. So likewise, there's security and privacy issues around that, images of your operation potentially leaving the premises, that sort of thing. So this is a good thought case around an edge processing application which just transmits the productivity information. It doesn't transmit images, for example. So there's a few thoughts around that, but again, this is something that it's not even that hard to do. The fact that I can figure out how to do it, and I'm not that much of an expert in this field. There are some pretty powerful tools available to people that take some of the, you have to be a data wizard to make this work kind of problem away from us. So those of us who are subject matter experts at something other than coding can make use of these tools. So I suppose my final practical point is around cognitive robotics. So I mean, robotics has been around for a long time, but cognitive robotics is really about robots that can learn how to do things better. So the example I'm showing up here is really about, this is a very complicated individual pick problem for a robot to handle. This is a loose bin of odd-shaped parts in random orientations. We're now very much seeing systems coming onto the market that are smart enough to be able to figure out, using a combination of vision systems, pressure sensors, all sorts of stuff, how to identify individual products in your warehouse, see how that they are different from other things, and learn how to handle every single one of those things well, which is one of the things historically you've needed humans to do, because humans can figure out how to adequately handle lots of random weird kinds of pick units. So where the state of the art has been goods to person picking systems, it's now goods to robot picking systems. And there are now one or two examples in Australia where goods to robot picking systems for loose stack bin random odd shaped parts are the example I'm thinking of is Sigma Pharmaceuticals in Sydney that went live, I think it was earlier this year, has a system that works like this, where you present the tote to the robot, and the robot picks from that, and it just sequences that out. So that brings us kind of to the end. Here's the key takeaways as I see it. So the tech's actually kind of here now. It's not actually that bleeding edge. It's mostly mature enough that it can be applied without taking, an R&D kind of risk about it. My take on it is that actually, if you tried to sit and develop a really detailed strategy around this, you'd spend so long developing the strategy that the strategy would be outdated by the technology evolution. So it's actually not that expensive in most cases. So my advice is just start something. It doesn't cost that much. This is an environment where I think experimentation is the way to go. So what I'm saying is start something small, pick a pain point that makes a difference in your business if you get it right, and then just experiment with it. Try some stuff. A trial real-time location system will set you back probably $5,000. And that's not a big amount of money in a new technology adoption kind of environment. So we'll leave you with a final thought. An AI generated this PowerPoint slide for me from bullet points. So I didn't pick these images. I typed in the bullet points at the bottom, and this is what I got back. And it's not quite there, but it's pretty close. So I thought that was a useful point to end on, is that even buried away in my PowerPoint, there is an AI working away for me. So it's subtle, but it's there. Anyway, so that's all the slides I have. I'm open to questions. Rob?
Yes, we have some questions come through.
Fantastic. Good.
So
not cricket thing.
Yeah, quite a few actually. So look, I'll start from the first one. First one comes from Noel Thompson. Noel wants to know, what are the key principles around ownership of data?
Oh, that's an interesting one. I think that there's no one kind of way of thinking about that. And I think it depends what the data is and where it originates from. I think my approach to those sorts of things is to take a risk-based approach to it. So what happens if we lose control or ownership or whatever of this data? That can range from issues around privacy to issues around, cybersecurity is a big one, right? So as much as some of this technology is fantastic, if hackers get into it and it's all connected, you've seen Toll get taken offline a couple of times this year. You've seen Lion Brews has been down for a while. So I think individual organizations need to look at it and think about it from a risk perspective. The only other thought I have on it is, if you've heard the phrase that if you're not paying for it, you're not the customer, you're the product, which is where, Facebook doesn't cost you anything for a reason. Those data centers don't pay for themselves. So, everybody's making even if they don't realize it, everybody's making a trade there, that they're trading their personal data for a service, and they lose control of that, because who reads the user license agreements? Fun fact on Facebook, for example, is even if you're not on Facebook, Facebook knows who you are and it has a profile sitting there for you. So you have your own digital twin. If you know anyone that has Facebook, you've got a digital twin, and Facebook has it, and they are selling that data to people. So, you talk about principles around data ownership, and it's the Wild West as far as I can tell. It does need some thought.
Right, cheers. The next question comes from Mark Geneva. Are there many specialized packages or products that wrap up a value proposition available either as a service or a software offering for particular industry verticals, even if we are past the trough?
Yes. So I think there's probably more than I know. I wouldn't say I know even the tip of the iceberg in this area. If you can describe if you can describe a pain point or a problem in your business, it's very likely that someone has created some sort of software, some sort of either digital service or digital product that is designed to address that problem for you. I think some of them are incredibly specific. I've seen some that are things like, a service that allows you to interface between a wide variety of robots working on different systems in your warehouse. So you can fleet manage the whole thing from one interface, and you can get them to talk to each other. And all it is a middleware product that sits in between all these different systems and can get them to talk to each other. That's got a value proposition, because interfacing those things directly to each other times lots of different variations of that is hard. And would involve engaging with lots of different parties and lots of software engineering stuff. So, my point to that is, if you can describe a problem and you can Google it, you almost certainly find someone's developed something for you.
Great, thanks. The next question comes from Steve Harris. Are you aware, Richard, of relevant or good sources of ROI information that can be used to build support for formative change thinking inside organizations? I'm particularly thinking about small wins rather than the slam dunk.
Yeah, that's a good point around looking for the small wins. It's hard to know, because it's so there's so many different sources. You depending on what thing you're trying to make stack up, you would go to lots of different places for those sorts of things. The research that's there that I know about, a lot of it originates from places like the big four management consultancies run a lot of research on that kind of ROI question. So there's often white papers available from the likes of Deloitte and PwC and EY and those sorts of places around case studies and ROI kind of examples. A lot of the time, systems or service vendors can point you to case studies that they've been involved with where they're able to publish an ROI. And those are quite good, because they're usually specific, and often you can find one that's relevant to your market and relevant to your maybe your geography, New Zealand being the operative question. There is university white papers out there from the likes of Harvard Business School and MIT and those sorts of places, if you want to look in those sorts of environments. But yeah, usually a good trip through Google will generally find you something. The danger is being too biased towards wanting it to work and finding anything online that justifies it is quite easy, actually, and can get you in trouble that way. So you probably want more than one source and a bit of a variety there to make yourself confident. But again, I think coming back to the experimentation principle is, if I think I'm going for something that's not going to cost that much, I won't put too much effort into trying to justify it. I'll try and build a case around, I could spend $5,000 researching this, or I could just do it for $5,000 and see what happens, So I don't know, depends on the environment you work in, I suppose, as to how tolerant it is of those sorts of approaches.
Got another question here from Tom Street. During lockdown, there were plenty of examples where internet shopping failed to meet customer expectations. These were often related to inaccurate inventory records and restraints on physical courier capabilities. Is order sensing okay for Uber, but just too early for the logistics sector? Will the early adopters take the market or bleed on the cutting edge?
Oh, good question. I'm on the fence on that one. I tend to think that things like demand prediction is something that you need a pretty big pool of demand to be worth tackling, if you know what I mean. So Uber, because it's kind of got the market, it can justify that. Most New Zealand businesses are just not that big. There's only a handful that would possibly be in that sort of territory, and they're probably in the grocery sector. The domestic retail market is just probably not quite big enough for stuff like that. But if you've got an international base, then yeah, maybe.
And connected to that, Chris Lancaster asks, have we got the skills in our industry to move forward with these new technologies? And if not, where is the best training pathway?
Yeah, good question. I suppose my take on that is yes and no. So again, I'm trying not to sit on the fence and give you a real answer. I think New Zealanders, when they apply their the number 8 wire approach, I don't actually like, but it's got merit. It's got a lot of merit. But what I think gets missed in that conversation is New Zealanders are quite good at innovating stuff sometimes because we're quite good at working in multidisciplinary, cross-functional kind of ways. And half the time it's because we're a relatively small community and we know people. So you get a funny problem and you kind of know somebody that probably knows something about it and you pick up the phone. New Zealanders are actually quite good at working through tricky problems. And I don't think we should underestimate that actually, because I've worked internationally and the pathways are very much siloed pathways, and this kind of thinking and this kind of technology is really multidisciplinary and really cross-functional. So we have a pretty good tech sector in New Zealand, but it's maybe not a logistics tech sector. So what I think we should be doing is we should be working with the tech sector that is here and marrying up what we know about logistics and what we know about the New Zealand context, because it is different. And you will have seen Australian companies try to operate in New Zealand and scrape a few knees trying to figure it out. I think we should be working our networks internal to New Zealand and external to New Zealand and getting the people together to fix whatever it is that's bothering us. In terms of training pathways, it's a good question. I think we're going to have to make our own, and I think we're going to have to make it through experience rather than training in a lot of senses. I cannot, I'll put it in perspective. In my business, I cannot hire people with the right technical training because it doesn't exist here. It has to be something that you get through. I'm making a decision to mostly invest young or hire internationally and build people that way because people are not graduating in something relevant to what I'm doing. So, I'm having to make it myself, and I don't think most organisations in New Zealand probably in similar kind of problem, I think.
Okay, now last 2 questions. So first one from Kerry Ann Tankate. Do the sensors that you talked about earlier come with software data capture, or do organisations need to invest in this technology as well? There is, of course, getting it and then doing something simple with it, but where does it really need to go to be useful?
I think there's a spectrum there from you can buy some sensors and you can do your own acquisition stuff, or you can buy turnkey systems that do exactly what you want them to do, or you can work with a specialist consultancy or a development agency or something that will configure something for you. I think my take on that is, I'll give you an example. And this sort of thing bothers me. So there are things like Crown Equipment is offering forklifts that have real-time location systems as an option, but it's a proprietary system that's embedded in the forklift, and the software associated with it is designed to do fleet management and forklift-centric things, and it's not open to talking to other software and other systems. So it's a packaged thing. And so from my perspective, that bugs me because I want to be able to tap into that data source. So I think we're entering a time where things that interface other things are probably where it's at for that sort of stuff. But as I say, as much as the sensors and the acquisition technology is emerging, so are systems that solve that kind of problem. Again, anyone that's tried to interface a WMS to anything else knows that that's hard and time consuming and costly. So what we're seeing emerging is a class of software that is simply there to sit between a WMS and other things and do stuff that the WMS is hard to reconfigure. So I think I don't know if I really clearly answered your question there, but I think if you look around, you'll find packages that can interface other things together, and then it's kind of about mixing and matching the things that you need for your business. But if that modularity trend keeps going, and it will, these things should just kind of connect. And we should be able to do things with that information relatively easily from that point onwards.
So the final question related to that, Richard, is that in the market at the moment, if you look at transport management systems, are there any out there that are leveraging these new technologies already and leveraging them well that stand out, particularly from your point of view?
You managed to pick the thing I don't know a lot about, which is transport management systems. So I don't think I can meaningfully answer that, unfortunately. I believe that there are. I just don't know what they are. I'm afraid. From what I've been told, those systems are out there from people that I would trust to know. I just don't have any direct experience with them, I'm afraid.
So if we bring it back to logistics management or warehouse management systems, any particular ones you think either locally developed or internationally have been being really well applied in New Zealand right now?
No, not really. A lot of the really interesting stuff is actually going on in the execution systems. But it's all emerging and evolving all the time. So, the execution systems are really coming from systems vendors more so than the WMS vendors. So, automation systems come with the execution system, or whatever your system is, there's usually a layer that sits in between the WMS and the stuff that happens on the ground, and that's the execution system. That's where I think the really interesting stuff's been going on recently. But the WMSs are starting to catch up. So, I don't know, it's a complicated question to answer because some WMSs have things that are in the territory of execution as part of them. So again, I'm not sure I really am able to answer the question well. All the tier one stuff is certainly thinking about this stuff and definitely doing things in it. I think it's in varying levels of implementation.
Well, Richard, thank you very much. And on behalf of everyone present, thank you very much for a very thought-provoking and interesting session tonight. There's a lot for us to take in, and this session has been recorded, and we'll make this plus your slides available to members afterwards. I would also like to just thank once more Tom Street, who's with me on the CILT Northern Committee, for introducing Richard to us and putting on. It's our first webinar tonight, and I think we did okay, didn't we, eh?
I didn't know it was first.
Well, it was the first, so we didn't tell you that. But hey.
No, we didn't tell me you were going to record it either, by the way.
No, yes, no.
I'm okay with that, by the way.
The technology, we don't need to tell you all the sensors we've got in this little box of ours. But look, thank you very much once again, Richard, and on behalf of all of us, we look forward to having you back at some stage soon, because I think this is not the last, at the end of the conversation by any means. It's only the beginning. Members, we're actually running another webinar next month to do with COVID response in the supply chain, and you'll be getting information about that very shortly. So thank you very much for attending tonight, and Richard, thank you.
All right, thanks everybody. It's been fun. I've enjoyed myself. It was actually easier than I thought it would be, so that's good. And look, I hope everybody got something out of it, and I hope you take something out of this that you can use at least, even if it's just something to think about. So thanks for having me. It's been great, and yeah, look forward to coming back sometime and maybe giving you some case study or something different. I don't know. We'll find out.
Look forward to that. And Richard, thank you very much once again, and good night to everyone. Thank you.
Right. To everybody.